Hello! Today we're catching a Falcon Super Heavy booster. The current tactical task, as it was announced in the interview of Elon Musk to Robert Zubrin, full and fast reusability, as the strategic goal is to create a self-sustaining and autonomous colony on Mars. And in the same interview, Elon suggested that to achieve a foreseeably positive result in this field requires an increase in the pace of scaling agility in space development. The current pace must surpass what SpaceX has achieved over the last 15 years exponentially. That is, it must surpass what has already turned the industry around. In brief, rather quickly according to the planning horizons existing in the industry, the idea to create a light Falcon 1 rocket coping with the launch into orbit was realized and rethought as part of the expansion of the already existing commercial niche in the creation of a heavy Falcon 9 rocket. And now we have the most reliable launch vehicle in history, which as a consequence of partial reusability, with each repeated use significantly reduces the cost of launching a kilogram of payload into low Earth orbit. The next stage, naturally, was the creation of even cheaper due to the transition from aluminum to stainless steel, more payload, and also fully reusable orbital system Starship. What I have just described is not possible in the paradigm of space exploration as it was from the 1940s to the 2010s. It is an event that critically requires a combination of a superior scientific and technical base and the use of the most progressive methods of achieving the final result. And as part of scaling up the miracle that was created by a relatively small team of a private company, it is necessary to accelerate innovation in development and significantly scale up what is happening. Again, since the development is private, instead of a narrowly defined local result, it is scaled to the largest possible volume. As it is obviously important for the business to get a leading position, bringing in more volume provides an opportunity for the manifestation of qualitatively new results and the emergence of previously non-existent areas of activity and opportunities. But back to catching a booster on a nice day. The fastest way to catch a booster is to catch it right above the launch table. Smoothly and quickly place the next chip on it and prepare it for relaunch in every possible way. Here and below we are talking about the first of the service towers and its infrastructure. For some reason, the refueling mast is going to fill the booster itself and also into the technical hole from which boiling oxygen is usually vented in order to fill the volume more completely with liquid component. Most likely it is because we are watching fiction. In an ideal world, everything works like this. But let's imagine a situation where a booster is in the process of catching a booster. The catching sticks start to converge, and suddenly, for some reason, they come back as if frozen halfway back, and the surface mass tries to hide behind the tower. All this happened because for some unknown reason the booster landed not exactly where it should do it in normal mode, but on closer inspection, it lands somewhere clearly off to the side. The outcome of such behavior is quite predictable. And no, we're not happy with that outcome. In the real world, there's a lot of returning boosters, and there's only one table. And it's not just an extremely important building, but the entire infrastructure around it. You can't have any launches without them. And if, according to statistics, The cost of launching the system goes down with each launch. Then the probability that there will be an emergency something wrong only increases. Structurally, catching the booster not over the starting table is possible just over the place where it and the ship are brought from the factory, and another advantage of this place is that there is nothing but concrete around. And even if something goes wrong, it is possible to put everything in order quite cheaply by patching a new patch of concrete. And what is represented by the high starting table in this tower will be transformed in its subsequent iterations. While this video was being created and edited, a second tower was erected, which is planned to have a not-so-high launch pad, which will allow not to lift products comparable to skyscrapers to a height, but also to increase the size of the Starship system even more. And even 15 meters may not be the limit, because in addition to deducting the height of the launching stool, it is possible to move the fasteners for which the booster and the ship are raised a little lower. Of course, SpaceX has a huge practice of first stage return, but due to many reasons, one of the most important of which is the extreme increase in size. The avionics of all the components of the Starship system is completely different from that of the Falcon 9 first stage. Therefore, it is necessary to develop practical skills to return to a given point, exactly to a point with a very small margin of error. Both the booster and the ship needs to park with much smaller tolerances than the Falcon 9 booster when landing on a floating platform. This is also to be learned on a live Mechazilla. If the construction itself, with supports poured in concrete, inspires a sense of confidence in the achievements of science, then quite different looks devices for picking up on the fly, directly grabbing sticks. The claw copes admirably with lifting to the height of the booster and the ship. But everyone who has ever met with a powerful and unshephable metal I-beam knows very well that if it is extended 3 meters without additional support, it sways noticeably at the end. The sticks for booster and ship fishing have, of course, much more stops and stiffeners in their construction, but they also extend to a much greater distance. It does not really matter what they are made of. If you continue to increase the size, then from a certain point you can introduce the characteristic of bulkiness. The way out is simple. You have to step on your own to make the length of the grasping sticks smaller. In an interview with Tim Dodd, Elon Musk mentioned that their size will be such that they will extend literally a meter or a meter and a half from the position of the hooks for which the technique is caught. The latter can also speak to the achieved accuracy of landing. That is, we will saw. How it will look like after the change of design, we'll soon see. And this is another of the arguments why you can catch the booster without considering possible damage to the Mechazilla legs. They still need to be redesigned. And this hot booster, presumably after the 5th test, is immediately sent to investigate the condition of the engines after capture, as Starship's orbital boosters have not been captured before. In addition to the obvious need to pretest and refine the functioning of the gripper sticks, there was an unexpected bonus. Parts of the second service tower assembly arrived from Florida, including another set of gripper sticks. So even if something unexpected happens to the original pair during testing, there is always a backup. And testing can begin without waiting for the new model to be built. After a series of tests on the Mini Buster, the structure is reinforced at the mounting points of the pipes that make it up by welding reinforcing profiles, and shock-absorbing devices are installed on the rails themselves. In addition to shortening the length of the gripper sticks, instead of or together with this, it is possible to fight against swaying by sending, at the right moment, a pulse in the opposite direction, possibly reactive, which compensates the swaying at the gripping point and during the gripping. Each of the elements of the system undergoes a huge number of changes literally with each new launch. Having talked a little about the components that ensure the continuity of Starship launches, it is necessary to mention the part of the Starship system, for the sake of which the things we have talked about earlier were built and constructed. The Starship. At the moment, it is the only spaceship, due to its size, which can be used for manned interplanetary flights. It is actually designed as a colonial ship for Mars. The road there can be considered open after successful tests of orbital refueling. A small acceleration pulse, 3 to 9 months of travel, depending on the relative positions of the planets. And there's Mars. It's enough to slow down a bit and roll smoothly into its gravitational vortex. Somewhat more difficult in the case of a flight to Venus or Mercury. Then you have to take into account the attraction of the Sun. About the Sun, it is necessary to remember that it is about 99 integer and 9/10 of the mass of the solar system. It is the most important storehouse of our world's matter, baryonic matter, of course. As for Mars, which in terms of colonization at the moment seems to be the most preferable, then, although the duration of the year there is twice as long as on Earth, and the change of seasons is caused literally by the approach and distance from the Sun, and not as on Earth by the tilt of the axis, there is a big positive bonus. The duration of a day on Mars is 24 hours 37 minutes and 22 seconds, which is very close to the duration of our day, which in turn is 23 hours 56 minutes and 4 seconds. There is a highly rarefied atmosphere, 95% of which is carbon dioxide, followed by nitrogen, argon, oxygen, and carbon monoxide. There's water on the surface. Mars is a major strategic target. Therefore, Starship has developed an engine that can be fueled by the most abundant resources on Mars, the oxygen-methane engine. It is currently in its third iteration and is something quite phenomenal, judging by its stated performance. Let's wait for it to be installed on the next iteration of prototypes. The next role of Starship is that of a space activity that is a continuation of an existing tradition. Access to orbit expeditions throughout the solar system, and even that new area of activity of creating and maintaining satellite constellations. What is the system and the ship itself? They are essentially a universal system. Any one-size-fits-all solution could usually be a compromise, equally ill-suited to any given task. This would be true without the transportation system's ability to deliver cargo cheaply into orbit. In the first time opening up space to human initiative, not government necessity. It is a tool for solving tasks, not a puzzle with squeezing as little weight as possible into a tiny space. 67 years after the flight of the first artificial satellite, a distance equal to the length of the Earth's equator is still considered deep space. In the space industry, the Starship system is doing the same damage to traditional means of space transportation that automobiles have done to road vehicles. We don't yet know exactly what can be done in space. Such an opportunity has not yet been presented. But the same constellations of communication satellites will not let the industry roll back to the previous state. There are already too many successful projects, and the benefits are obvious. The cheap reusability of Starship opens up another possibility, which, by the way, was announced quite a long time ago: its use as a new mode of transportation. Within an hour it is possible to get to any place on the planet. Elon Musk voiced the possible cost of production in the region of $5 per kilogram, and even if you add here 100% of the profit in the fund for the development of the company and the development of Mars, it is still a ticket to Australia will cost about $800 to $1,000. During the 5th flight test, the plan is to fly just to Australia, which makes much more sense in the case if it is necessary to work out the possibility of just such a development. The avionics will be the same, as in a suborbital jump from the Gulf of Mexico to Australia, and from there to Hawaii, or in the case of an orbital turn with a landing in the Atlantic. And so it will be possible to carry out the planned tests and to find out some peculiarities of the new route. Don't be afraid, baby. Help is on the way. Judging by the name of the rescue boat, everything is fine. For those who dozed off and missed this video, I'll summarize what we talked about. After figuring out where and how to catch the booster, there will inevitably be another test run, in this case, the fifth, in which an attempt will be made to rescue both the booster and the stranded ship from a floating platform, not in Hawaii, but off the coast of Australia, because it's more interesting that way.